All right, enough with the theory. Let's start coding. So we're going to implement a very simple AI for an enemy that chases the player around, and if he goes too far away, it stops chasing him around. So without further ado, let's jump into Unity. Okay, so I'm here in Unity and I've prepared a little project. You can download the finished project in the description. And if I just start this, it's very simple. So right now we have a player that can move around and we've got an enemy. That's this cube and it doesn't do anything right now. So what we want to do now is make the cube follow the player. And if I select him, I can already see I implemented two different ranges. The red one is the aggro zone. So if the player enters the aggro zone, the enemy starts to follow him around. And I've also got this gray area, which means that the enemy doesn't care about the player anymore if he leaves this gray area. So I've called this the deactivate radius. Not a very good variable name, come to think of it, but we'll stick with it anyways. So let's first have a look at what the code right now does. So here I've got the enemy script and there's a bunch of stuff up here that's not too important. Maybe what's interesting is the movement speed. That's how we control how fast the player moves. And these two are actually important. So this is the aggro radius. So when the distance to the player is below this threshold, he should follow the player. And if he leaves this threshold, he should resume to his original position, so to his start position. And I've got two methods that do exactly that. Move the enemy to the origin position or move him to the player. Right. Also in the update method, I always update the distance to the player. If you're not familiar with state machines, you might be tempted to immediately do a few if-else statements to determine if the player is within range of the enemy. But this comes with a bunch of problems. It works just fine, but a state machine is just a better way of doing this. And it's better because it's more extensible and it's also way more structured and doesn't become as spaghetti as if you do it with just plain if statements. All right, so let's kick this state machine off. So before we can do anything else, we need to define an enumeration or enum which holds the states our enemy can have. Now I've defined the enemy state right here. He can be idle, he can be aggro and follow the player, or return to its starting position or origin, how I called it. So this is only the definition of the state. Now I also need a variable that can hold the current state of the enemy. So this variable holds the current state of the enemy. And what I usually do is in the awake method, I hit this awake down here because I already do a little bit here. So in the awake method, I usually set the current state to whatever I want to be, the default state to be. In my case, I want it to be idle. Right. Next up, I want to do different things for the different states of my enemy. So I check if the current state equals idle. Enemy state dot idle, of course. And if that's the case, then I won't do anything. For now, it just doesn't do anything. Next, else if the current state equals enemy state dot aggro. If the enemy is aggro, then I want it to move to the player. And also what might be nice to make it a little bit more visible, I prepared this renderer variable here, and I set the renderer to the renderer on the game object. So I just say renderer.material equals aggro-mat. That's the aggressive material that I assign. So that way our enemy becomes red. And lastly, I also check if the current state equals this return to origin. And if that's the case, I want it to move to the origin position and set the material to the, I think it's called inactive mat. Maybe call it returning mat. And come to think of it, I might also change this to return to origin radius. All right. And yeah, if we already set the colors here, maybe we also set in the idle mode, we also set just the color to the neutral material. So that way we can immediately see by the color which it has, in which state it currently is. Now, I'll also leave it private and set it to serialize field so we can see it in the inspector. Okay, now let's look at the enemy. And we can see I need to assign the returning mat again. Let's make this gray one. So save it. And now let's start. And it turns yellow because initially I set the state to idle. If I set it to aggro, that works too. Back to idle, back to aggro, and return to origin. So basically it works, but I have to set the states. So there's not much of an AI, so I have to do this myself. And that's because we only set the states, but we didn't set the transition between those states. So what we're going to have to do is we will need to determine when the enemy switches from which state to another state. So let's think about this for a moment. If the enemy is in the idle mode, so if he's just standing there and waiting for the player to come into range, I can check if the, how did I call it, distance to player? Distance to player is less or equal to the aggro radius. Then we want to switch to current state equals the aggro state. So now, if he's in idle and the player comes too close, he switches to aggro mode. That's already quite fine. I'll just copy this. Now let's say the enemy is currently aggro and the player leaves the return to origin range, or how I called it, yeah, the return to origin radius. He should switch his state to return to his starting position. So let's do this. All right, so now if the enemy is aggro and it moves too far, it should switch back and go to its origin position. And lastly, let's check if he's in the origin position and he's very close to his starting position, he should switch to the idle. I might need to calculate the distance to origin. All right, let's do this. Okay, so if the enemy is 0.1 meter away from its origin, maybe even change this to 0.05, then it should stay, go back into the idle mode. All right, so that should be all the transitions that we have. I'll save this, enter. Okay, it follows me. I leave the area, it goes back. Okay, so we've already implemented the basic state machine. There's a little room for improvement. Actually, there's quite a bit room for improvement, but I'll keep that for another video. But one of the main things we should actually address right now is this huge block of code. So the enemy at this stage really almost doesn't do anything. It's very, very simple. And we already need quite a bit of code here, and it's going to get really messy if I would make this a little bit more complex. So what I usually do is to create a separate update method for each state. Okay, so instead of having all the logic inside of this main update loop, I create a separate update loop for each state. And that could look like the following. I get this stuff from the idle state and I cut it, and then I create private void update idle. So this is the stuff the enemy should do if he's in idle mode. And then I call this here. Okay. Then I repeat the same process for the other states. And now my main update loop looks way cleaner, and it works far better. I can even refactor this still a bit to only have look like this, and then you've got a good overview here right now. You could even use a switch case statement here, which might even be a little bit more nice than this one, but I'll leave it as that for now. Now, I'll give you one last very important advice. Only handle the transitions between states inside of a state. Okay, now what do I mean by that? People who are new to the state machine pattern might do something like this. They code in the main update method. They just check if, I don't know, the distance to the player is less than 2, for example. It might switch to, I don't have it right now, but it might switch to a melee mode, for example. Okay, let's add this one here, melee. Little typo here. And it might be rather tempting to do it because it's very quick and so on. But this kind of transition leads to huge problems. If you add a transition in the main update loop, this transition can be called from every state that there is. Now this might be fine with only 3 very simple states, but imagine you have 7 or 8 states. There it might be challenging to keep an overview about when it's fine to do this and when not. So I would highly discourage creating a transition here in the main update loop, and rather make every state responsible for itself. Okay, so every transition that you want to make should be made from the state where you want the transition to happen. So that way each state is contained in itself, and you don't have to factor too much about what happens in the other states. Now, this is a very simple state machine. It works fine, especially for small projects. This is totally nice. However, it has one big disadvantage. We cannot reuse any of these states because they are hard-coded into the enemy. Now imagine we don't have just enemies, we might also have critters who might act somehow similar, and we might want to reuse, for example, the update idle state and the return to origin state for different game objects in our game. That's currently not really possible because they are hard-coded into the enemy script. Now there's a so-called state pattern. This is a design pattern, and it's a standard approach to address this issue. And with this state pattern, you can reuse different states for different game objects. And that's what we're going to look at in one of the next videos. Now, I hope I could shed some light into how state machines work and what they're used for. I mean, they're really the most rudimentary AI that there is, but it works very fine for simple programs, like for platformers or, I don't know, for side scrollers, easy stuff like that. However, if you want to reuse different states, you might want to check out one of my next videos about the state pattern, because there we're going to look into that. And with that, I'm going to leave you for the next video.